Hi everyone, today we're going to head and take a look at lesson 5-4, analyzing graphs of polynomial functions. So our first example here is graph f of x equals negative x cubed minus 4x squared plus 5 by making a table of values. So here what they've done is they picked their x values and they found the y values or the f of x values. And then they plot their points. And then they're going to do, connect the dots with a smooth curve, is what we would say. Another way what we most likely would actually be doing this would probably go ahead and graph it in Desmos, pull up your coordinate points, and then sketch your graph. But as we look at this, we can tell that this is an odd degree polynomial. And the reason we know that is, one, the highest exponent that we see is a 3. 3 is odd, so that makes the function odd. We can also see that our end behavior is going in opposite directions. That's another clue it is an odd function. And we can see that our leading coefficient is negative. So that tells us that our end behavior, that as we go to the left or as we go to negative infinity, y will go to negative infinity or positive infinity. And as we go to positive infinity, y will go to negative infinity. We can also see that there's 3 x-intercepts or 3 zeros is another way we will look at it. And we have 2 turning points. So go ahead and determine which is the graph of f of x equals x cubed plus 2x squared plus 1. Pause the video to give this problem a try. All right, by graphing it, you should get C for your answer. All right, next we're gonna take a look at the location principle. Location principle is just saying that if I have, in this case, they're saying if I have a point that's below the x-axis and a point above the x-axis, somewhere in between I should cross the x-axis, is really all this is saying, in very much math speak. So in math speak, it says suppose y equals f of x represents a polynomial function and a and b are 2 real numbers such that f of a is less than 0 and f of b is greater than 0. Then the function has at least 1 real 0 between points a and b. Again, it's just saying that if you have a point above the x-axis and a point below the x-axis, somewhere in between, it's going to cross. You can go ahead and pause so that you have time to write this. So taking a look at our next example, we have determine the consecutive values of x between which each real 0 of the function f of x equals x to the 4th minus x cubed minus 4x squared plus 1 is located. Then draw the graph. They're really, this here where it says determine consecutive values, generally that means they don't want you to round your answer and you're going to actually have a decimal answer. They just want to know between which 2 points, between what 2 x values does it cross. So we can make a table of values. And if we look at it, we can see when we look at, we're going to take a look and see and look for the change of signs. So we're going to look here in the f of x column and see when does it go from positive to negative or negative to positive is what we're looking for. So we can see we change signs here and then we do it again and again and then again at 2 and 3. The note where it says it will have 0, 2, or 4 real zeros is because it's a 4th degree and zeros come in pairs. So you either cross 0 times, 2 times, or 4 times. In this case, we cross 4 times. So we take a look at the zeros and we're going to go ahead and help us sketch our graph out, and this is what we would get. We have zeros between x is equals negative 2 and negative 1, between negative 1 and 0, between 0 and 1, and then again between 2 and 3. Pause the video as needed. All right, so determine consecutive values of x between which each real 0 of the function is located. Again, pause the video so you can go ahead and try this on your own. By graphing this, you're going to see that you have 3 intercepts, one between negative 1 and 0, another between 0 and 1, and then another between 3 and 4. All right, for example 3, we have graph f of x equals x cubed minus 3x squared plus 5, and estimate the x coordinate at which a relative maximum and a relative minimum occur. So what these are referring to here, relative max and relative min, are referring to turning points. So where does your graph start going up and then start going down? So this would be a turning point. Or when does it start going down and then it starts going up? So this is a turning point. So here's a max and here's a min. So pulling up the table, what you're looking for is when does the sign, when you're going from negative 15 to 1, I'm going up, 1 to 5, I'm going up, and then when we say 5 to 3, we're going down. So I know I had to turn. And I said 3 to 1, well, that means I go here, and then 1 to 5, and I turn to go back up. So that's how we know if we're turning. So since the value f of x at x equals 0 is greater than the surrounding points, there must be a relative max near x equals 0. And the value at x equals 2 is less than the surrounding points, so there must be a minimum near x equals 2. Now, they're not saying that's exactly where it is, but that's just generally the general area is what they're looking for. You can go ahead and check this by graphing. The steps here you can't really do on the TN Inspire, so we're not going to worry too much on them. We're actually going to skip through. But this is what the graph looks like, and you would actually look for the intersections. In Desmos, they mark these points automatically, and you can click them and see the value there. That's one of the coordinate points that Desmos marks on graphs. They do mark turning points. All right, so go ahead and determine where the relative max and min are for f of x equals x cubed plus 3x squared plus 2. Pause the video to give yourself time to work it out. If you graph it and you either look at the table or you look at the graph, you should get that there's a relative min at x equals 0 and a relative max at x equals negative 2. All right, for example 4, we're going to take a look at a real-world example. We have the weight in pounds of a patient during a 7-week illness is modeled by the function w of n equals 0.1 n cubed minus 0.6 n squared plus 110, where n is the number of weeks since the patient became ill. Graph the equation. So we're going to head and graph this. We're only going to look at points 0 through 7 because it talks about a 7-week period. So this is where knowing about the fact that they're saying it's a real world example, that puts limitations on what we're actually going to look at and what's actually relevant to us. So that's very important. So here is our table of values for the equation. So we're going to head and plot the points and then connect with the smooth curve. The next thing we're going to take a look is describe the turning points of the graph and its end behavior. So we can't really talk about what happened before week 0. We can only talk about what's happening at week 0 and beyond. So I can see we have a turning point at week 4. They were losing weight and then they started gaining weight back. And then here we have for end behavior, as n goes to infinity and w of n goes to positive infinity as well. So we're going up and to the right. We're not going to look at the other end of the end behavior because we can only see part of it. What trend in the patient's weight does the graph suggest? So what do we see that happens here? So we're going to analyze, like in a real life, what does this graph actually mean? Well, if we look at it, we can see, well, when they got sick, they lost weight. They lost about a little less than 4 pounds, probably closer to 5 pounds. And then when they started getting better, most likely after week 4, they started regaining their weight. And last, is it reasonable to assume the trend will continue indefinitely? So the question is the trend going to continue going to increase forever and ever is really what you want to say is what we're looking at. And our answer is it might go for a little while longer, but it's not going to continue forever. Usually weights tend to flatten out at some point where that's where you live out unless you work out again. It's also likely that you can get sick again and lose weight again. So it's much more, it's not simply as, oh, I lost some, gained some, and I'm always going to gain some. That's what we have to look at when they talk about trends. And is it reasonable? It's not reasonable to continue forever. All right, go ahead and try graphing this one. Pause the video to give yourself time. All right, when you graph it, you should get a graph that looks like option A. Next, we're going to describe the turning points. So go ahead and give yourself a minute, pause the video to try out this problem. All right, so when we describe the turning points and the behavior, you should pick B. There's a relative max at month 2, and it decreases as the months go on. What trends does in the amount of rainfall received by the town does the graph suggest? Go ahead and pause the video to go ahead and answer this. All right, so you should get B, the rainfall increased the first 2 months and then decreased. And for our last question, is it reasonable to assume this trend will continue indefinitely? Yes or no? Pause the video to go ahead and pick one. All right, the answer should be no. As we all know, this doesn't continue indefinitely, and the key word here is going to be the word indefinitely. Some things that we look at is that we have seasons. We have a rainy season, we have a dry season, we have droughts, and then there's times when we have monsoons or hurricanes come in and we have lots and lots of rain. So it's not something that's just going to continue to drop, but it's likely to go back up based on seasons. That is the end of this lesson, and I will see you guys next time. Have a good day.